immediate value. I can understand that both of you have a lot of knowledge in this field, and so far I know about Dr. Shams. You are one of the most talented or genius product of our university, and I would request the young generation like you to carry on something. If you are really not convinced with what we will be presenting in this seminar, then come and see me at any time. Sorry, probably some of you might have misunderstood me. In fact, a lot of if you do this, then you come and see me at any time in my office. I will try my level best to convince you, so that we can set up some sort of experience to lay that is. Any more comments or questions, please?
Professor, to be discussed, not with certainty, but with the practical concept. In the bad Copenhagen days, when there was discussion on quantum mechanics and Heisenberg and Einstein were there, what I'm saying is what I had from Heisenberg and Einstein is but in various years back. So the recurring his memories of the Copenhagen days. And in the discussion between Heisenberg and Einstein in the Copenhagen days, at one point they had different views on the meaning of quantum mechanics. Einstein was against the probabilistic view, and Heisenberg was for the probabilistic view, and they were not agreeing, and the discussion was going on for 2 or 3 days, and both were going to die. At one moment, Heisenberg said, "You Einstein, that according to your principle, Einstein's principle, that a theory must have only observables. That which is not an observable should not be a part of a theory. This is known as Einstein's principle." Heisenberg invoked this Einstein's principle and said that according to your principle, that only observables can be answerable. It should be such something. When Heisenberg said it, Einstein laughed and replied to Heisenberg, "Do you believe it?" It's Einstein's principle that you can have only observables in the theory. And when Heisenberg invoked it, he laughed and he said, "Do you believe it?" You know, Einstein himself, he does not believe it or did not believe it. And that is quite possible. And in fact, almost the same, because everyone has its own background. All the observations which have been made after the grading phase, only one observation is like that. Knowing therefore, without knowing, we had special relativity background. So with that frame of mind, we have observed. We look at a different frame of mind, might be able to come up with a different observation. Yes. Thank you.
Thank you. In Einsteinian equations also, those equations have been given considering two equations. If it is true or if you can accept that one, I would request you to accept our ones as well. Say for instance, the time dilation in the transverse direction, that is not the movement of the...
My question is, at any time you should consider one direction, the direction of the motion of the particle.
Yes.
Why are you considering that two directions?
Yes, sorry.
I think...
if you follow my procedure... Sorry. Yeah, okay, sorry. Carry on. Sorry. If you follow my method, I calculated only the time time contraction in the longitudinal direction, and I have used the transverse number from Einstein's equations. That is not my construction. You did not notice it. I did not explain it anywhere. What I did, yes, in my calculation I have used only the and our equation is different from Einstein's one. And I consider this one as in the transverse direction and took the product of those two. One of those is actually calculated by us. Okay? So I have this. Or do you have any more questions?
Regarding the contraction of length, it is always transverse, and longitudinal contraction was never observed, since the theory. In the theory of relativity, it is said that there isn't any contraction along the lateral direction, along the transverse direction. So that is one thing. And second thing, regarding time, as the first questioner asked, we never heard of anything like transverse or longitudinal time. Time is time. My question is like the first question, like what do you mean physically by the transverse and longitudinal time? By time, it means time.
Can I make a point about this question? X, the time coordinate is switching transverse to the x-axis. So the contraction is around t, and that is transverse to the direction of motion. In that way, you can make sense of this transverse time dilation. The other question is, I think we can put it very simply, whether we can consider time as a vector. That is, I think, one of the most important questions. Because if you cannot assign a direction with time, then in physical sense, time, transverse and longitudinal direction does not have any meaning.
Okay. Let me answer the length. The relativistic effect on length has been derived or calculated in both directions. In one direction, it remains invariant, and in the other direction, it is contracted. So, my question is, if it can be done for length or measurement on length in both directions, why should not it be done in the case of time also? And in fact, in the calculation, I cannot explain right now. If I explain it right now, but probably so far I know they consider in both directions, but they did not find anything in the longitudinal direction. That's why they don't mention it. And as I explained to you, people just a while ago, that we have got the relativistic effects in both directions. That's why we have to mention that it is in the transverse or it is longitudinal. And he had only one quantity, that's why he did not mention it. But those are actually calculated or formulated in that. I'm very sure about the length measurement. And in that book, in one book I have seen that one. That in the transverse direction, A is equal to long. And in the longitudinal direction, A is equal to 1 minus B square or C square. So, this is not a new concept in fact. This has been done before, but they came up with the result that in other direction it does not vary. That's why they talk about only length or time. Sorry, am I clear, sir?
Still it is left for experimentalist to do this, as Dr. Nakib Ahmed and Dr. Shamsuddin Tariq. They are the young, energetic, enthusiastic, and also talented scientists, and we are proud of them. So I think the task is left for him to verify experimentally. Thank you.
Science and Technology today, and Professor, Department of Physics, University of Rajshahi, kindly take his seat as the chair of the session. Thank you, sir.
Of today's international conference. Today, the first speaker will be Professor Rajshahi Ahmed, and the title of the paper is Incompatibility between Einstein's postulates and Special Relativity. So I will request Professor Rajshahi Ahmed to come and present his paper.
the theory of relativity is built on Einstein's postulates. And therefore, to say that in comparison between Einstein's postulates and special relativity seems thoroughly
our view of relativity. Anyway, so other thing from this result comes up, and we can firmly conclude now that there are two types of velocities. Hence, to understand the motion-related phenomena in physics clearly, we need to have some sort of rules of transformation from one category of velocity into the other one. That is what has been done. Next, please. For the transformation from Galilean to relativistic velocity, let us consider that the velocity u is equal to n times the minimum velocity u prime. I talked about the minimum and maximum values of relative quantities yesterday in the afternoon session. Then, according to Galilean rule of multiplication, u is equal to n u prime, where u is a Galilean velocity, and to convert it into relativistic velocity, again we need to apply relativistic multiplication rule. Here, ur is the relativistic velocity, and it is n times the minimum relativistic velocity u prime, and it can be given by this expression. I'm having some problem with this. Can anybody sort it out? Then, since u prime, if you can remember, I gave a relationship for the minimum velocity and another relationship for maximum velocity, which was in fact inverse of the minimum velocity. And I showed the calculated value for the maximum velocity, which was 1.36 times 10 to the power 50 times c. So the minimum value of velocity, you can understand the inverse of that quantity, how big it can be. Anyway, definitely it is very, very less than the speed of light. So under that condition, we can transform the previous we can transform these expressions into exponential functions like this, n u prime over c, and I have already shown that e is equal to n u prime according to Galilean rule of multiplication. Replacing this n u prime by u, we get this expression, which ultimately goes to this expression. That is, ur can be expressed as a tan hyperbolic of u over c, and this equation represents the rule of transformation from Galilean, this one is Galilean, to relativistic velocity. Then let us see how we can transform relativistic velocities into Galilean velocity. Just a while ago I showed that the relativistic velocity is related to the Galilean velocity by this expression. Therefore, u over c is equal to tan hyperbolic u over c. Now, from the mathematical identity, exponential a is equal to this expression. If we take the logarithm on both sides, we get a equals logarithm of this expression. Next, please. Therefore, E over C becomes Therefore, E over C becomes that expression, and using E over C, sorry for the interruption.
In the meantime, I see that there is very little difference from the G and gamma. You are defining that non-Einstein colleague telling him that until I finish, I won't say it. I think you should ask a question of
Logarithm of this quantity, and therefore we can say that E equals C over T logarithm of C plus QR divided by C minus QR. And this one represents the root of transformation from relative into Galilean velocity. Next, please. Now, I would like to talk about the implications of the results. If we put A equals E over C in this mathematical identity, then we get exponential E over C is this. Now, using U over C equals tan hyperbolic E over C, we get E exponential E over C is equal to VT over C plus QR over VEL. Now, yesterday I talked a lot about these two quantities. VT is actually the relativistic velocity in the transverse direction, and VEL is the relativistic velocity in the longitudinal direction. As before, next. If we take the product of these two quantities, we get VEL into VT equals C squared. And from such relations in my yesterday's talk, particularly in the afternoon, I derived the expressions for the relativistic quantities for all other relative quantities, just from a single one. That's why in one stage I claim that we have been able to find out a set of equations which are completely consistent, self-consistent. There are about 6 set of equations, but there are about 6 relativistic quantities like mass, time, length, momentum, velocity, energy, and if we consider a single relativistic quantity and consider the related equations out of which we can get all other equations. So, similarly, from this equation we can get the expressions for the relativistic relations for all other related quantities like mass, time, length, momentum, energy, and we have derived it, and those will be shown in the proceedings anyway. But we can generalize those expressions by this relation. XEL into XET equals X naught squared, where XEL represents where X is any relative quantity and EL represents its value in the longitudinal direction and ET represents its value in the transverse direction, and 0 means its value at rest. Next, please. From that result, we can conclude once again that the velocity in the gamma factor is relativistic, which cannot exceed C.
Dr. Ahmed yesterday probably showed relativistic speed c corresponds to Galilean speed infinity. On the other hand, the velocity of neutrinos measured by some scientists being slightly higher than c, that is, E equals 1.02 c, is Galilean. The variations of mass, in particular the increase at this particular velocity in both views of relativity, is going to be shown now. Next please. Next please. In Einsteinian view of relativity, but with V replaced by this one should be QR, means the relativistic velocity. For U equals 1.02 c, in this expression, UR over C becomes approximately 0.77. And using this value of UR over C in this relation, which means the gamma factor, then it becomes equal to 1.57. This result indicates that the transverse mass increases by a factor of 1.57 according to Einstein's view of relativity, but the velocity must be considered as relativistic velocity in the gamma factor of Einsteinian view of relativity. Now let us see what happens in our view of relativity. The next please. No. Yeah. Since the velocity in the G factor is Galilean, we don't need to use any other method. So we can directly put V equals 1.02c in this factor, which gives us a value of approximately 2.08. It means the mass increases by the factor of 2.08. Again, there is no problem if neutrino speed exceeds the speed of light. Next please. Thus, we conclude that there is no problem for neutrinos traveling faster than light so far their mass is concerned. Hence, the dilemma of neutrinos traveling faster than light is resolved. We make the following conclusion now. Neutrinos have won the race with photons, but Einstein has not lost. Thank you very much for patiently listening.
Thank you very much for this very exciting talk, and I'd like to open the session for questions. Any questions or comments?
That non-Einsteinian binomial. So this is the first term of the binomial response. That's all. So that's quite interesting question. Sorry. I can't see it from here.
Can your name and that will identity first.
Here from my community. Right. Okay. That's quite interesting question. In your opinion, it is the approximation of Einstein's equations, but in our opinion, Einstein's equations are the approximations of the non-Einsteinian equations. In fact, if we convert the particle velocity into relativistic ones, then I showed it in my demonstration that it goes over to Einsteinian equations, but under the condition when V is heavily less than C, much less than C. But if you apply binomial theorem to convert Einsteinian gamma factor into G factor upon Einsteinian case, then again we have to apply that for V much less than C, it becomes equal to our factor. And the other thing, although we did not mention in our proceedings as well, or in our detailed paper as well, But what I can say that our equations are the consequences of energy conservation law directly. So our feeling is our equations are exact and the other equations are approximate.